Good day and welcome to AP Calculus Homework Solutions from section 3.9b. You can open your book to page 226 and we're going to work 21, 23, 27, 41, and 42. So number 21 says that the measurement of the side of a square is found to be 12 inches with a possible error of 1/64th of an inch. Use differentials to approximate the possible propagated error in computing the area of the square. Okay, so first of all, what we need to do is get an equation for area. So area, if the side of the square is, you want to call that x, area is equal to x squared. All right, and then we want to take the derivative with respect to x. So dA dx is going to be 2x. And then dA is 2x dx. All right, so now it's just a matter of plugging in. That's going to be 2. The side of the square is 12 inches. And then the possible error is 1/64th of an inch. Of course, that's plus or minus. So that would be 24 times 1/64. So that would be plus or minus 3/8 inches squared. So that would be our propagated error, including the measurement error of 1/64th of an inch, because the error is going to be greater since you end up squaring it. All right, that's 21. Let's do 23. So 23 says the measurement of the radius of the end of a log is found to be 14 inches with a possible error of 1/4 inch. Use differentials to approximate the possible propagated error in computing the area of the end of the log. We got to assume the area that the log is a circle. All right, so our equation would be area is equal to pi r squared. So I would expect you to know the area of a circle on the test and the area of the side of a square on the test. All right, so our derivative, dA dx, would be 2 pi r. So dA is equal to 2 pi, this would be dr. 2 pi r dr. All right, so our propagated error, dA, is going to be 2 times pi. The radius is 14 inches. And then the error is given as 1/4 of an inch, so I'm going to go ahead and just write that as 0.25. Okay, so 2 times pi times 14 times 0.25. I'm going to keep the answer in terms of pi, so that would be plus or minus 7 pi inches squared. All right, pretty cool. So let's move on to number 27. All right, 27's got a part A and a part B. So says the radius of a sphere is claimed to be 6 inches with a possible error of 0.02 inches. Use differentials to approximate the maximum possible error in calculating the volume of a sphere and the surface area of the sphere. Okay, so we're just doing A and B. We're not going to do part C on this. Okay, so first of all, the volume of the sphere, it does not doesn't give that, but if you'll look in the front of your book, on this page you've got all the formulas. So we've got both the volume and surface area formula there. All right, so got to flip back to page 226 real quick. All right, so it says we've got the volume of a sphere, so that's 4/3 pi r cubed. So we're going to have to take the derivative with respect to r. That'd be 3 times 4/3 would be 4 pi r squared. Don't forget that exponent. All right, and then dv is 4 pi r squared dr. So now we can plug in. We've got 4 pi. The radius is 6. Don't forget to square that. And then the error is 0.02. So if we leave that in terms of pi, and don't forget it's plus or minus because it could be greater or less than 2.88 pi. And this is going to be inches cubed since it's volume, and you'd have inches squared times inches, so that'd be inches cubed. All right, part B, we're talking about the surface area. So it gives you in the front of the book the surface area equation. That's 4 pi r squared. All right, let's call this SA, 4 pi r squared. So taking the derivative with respect to r is going to be 2 times 4, 8 pi r. So dSA is 8 pi r dr. And now we can plug in. We've got 8 pi. The radius is 6 inches. And then times 0.02. Okay, I'm going to leave it in terms of pi, but that is going to be plus or minus 0.96 pi, and it would be its area, so it would be inches squared. All right. Now, sometimes, you might be asked to do it in terms of that is the error of the volume. You might actually want to calculate the volume. 4/3 times pi. The radius is 6 cubed. So another way to write this, I just want to do one of these, especially if you're going into engineering. You would have, 4 divided by 3 times pi times 6 cubed. So that's 904. The way you could write this is 904.78 inches cubed plus or minus 2.88 pi inches cubed. A lot of times, so that's what the volume is. Our measurement of volume is that 904.78 plus or minus 2.88 times pi, because it could be plus that or minus that. So that's what the plus or minus means there. It could do the same thing on part B. Okay, let's finish this out with 41 and 42. I kind of find these problems really interesting. So 41, we want to estimate the fourth root of 624. Okay, so our equation would be y is equal to x to the 1/4 power. Okay, so we want to pick an easy point nearby. Now I would pick 625. The fourth root of 625 is 5. So our point nearby would be 625, 5. So we'll get y prime is 1/4 x to the minus 3/4. That's the same as 1/4x to the 3/4. So our tangent slope is 1/4 times 625. So you're not plugging in 624 yet. You're plugging in the point nearby to the 3/4 power. Okay, so let's go ahead and get that. So 4 times 625 raised to the 3/4, so 0.75. So that's 500. So our slope is 1/500. A tangent line equation then would be y minus 5 is equal to 1/500 times x minus 625. So y, that's going to be our estimate, is equal to 5 plus 1/500 times x minus 625. So now we're going to plug in 624. So that's -1, right? So it's 5 minus 1/500. So 5 minus 1 divided by 500. And that's 4.998. Well, that number makes sense because it's real close to 5. Let's see what our calculator says the fourth root of 624 is. So 624 raised to the 0.25 power, 4.997998. I'd say that's pretty close to 4.998. So you can always check your answer on these, so that's pretty good. But on the test, you have to show every bit of this work. All right, you can't just put the answer in your calculator. But you can see if maybe you did something wrong by checking it with your calculator. All right, 42. We have 2.99 cubed. So the point I would pick nearby would be 3 cubed, right? So our point nearby is x is 3, and 3 cubed would be 27. Our equation then is y is x cubed. So y prime would be 3x squared. Our tangent slope would be 3 times 3, plug in the x squared. Our tangent slope is 27. Tangent line equation would be y minus, now remember we're still using these points. We don't plug that 2.99 until the last step. So y minus 27 is equal to 27 times x minus 3. So y is equal to 27 plus 27x minus 81. Let's go ahead and do that. That'd be y is equal to 27x minus 54. Okay, so now let's get our estimate. Y of 2.99 is equal to 27 times 2.99 minus 54. right? That's 26.73. That makes sense because it's real close to 27. Let's go ahead and see what 2.99 cubed is. It is 26.7308. So I'm pretty happy with that. And that'll do it for this homework solutions video, and I will talk to you in lecture 3.10.